Hello learners, welcome to Sure Question Academy. Please watch the videos, like and subscribe to the channel.
Hello. Welcome to today's physics session. Before solving this classic board exam question, let's take a moment to really understand what it's asking us to do. Part A, Sub-question 1, is a famous conceptual trap. We need to clearly state whether the electric current and the potential difference, or voltage, will remain the same or change across three bulbs. We have four specific cases to analyze. Case A asks us to imagine three bulbs of the exact same wattage connected in a series circuit. And Case B asks what happens if those same identical bulbs are rearranged into a parallel circuit. Then, things get tricky. Case C asks us to consider three bulbs of different wattages connected in series. And finally, Case D asks what happens to the current and voltage when those different wattage bulbs are placed in parallel. Let's dive into the answer for Part A. The behavior depends entirely on Ohm's law and the circuit structure. For same wattage bulbs in series, the current remains the same through all bulbs. And since their resistances are equal, the potential difference across each bulb is exactly the same. In conclusion, current is the same and potential difference is the same. For same wattage bulbs in parallel, they draw the exact same current. And the potential difference is always the same across parallel branches. Conclusion: currents are the same, potential difference is the same. Next, for different wattage bulbs in series, the current is still the same. But different wattages mean different resistances, so the potential difference divides unequally. Conclusion: current is the same, potential difference is different. Finally, for different wattage bulbs in parallel, they draw different currents. But the potential difference remains the same across branches. Conclusion: currents are different, potential difference is the same. Now look at sub-question 2. We are given two identical 24 ohm resistors and a 6-volt battery. We must calculate the power consumed when they are arranged for minimum resistance and when arranged for maximum resistance, and then find the ratio between these two power values. Moving to sub-question 2. The power consumed is calculated using P equals V squared over R and P equals I squared R. Remember, for series we add the resistances, and for parallel we add their reciprocals. To get minimum resistance, we connect them in parallel. Using the formula, R min equals 24 times 24 over 24 plus 24, which is 12 ohms. Now, the current I equals V over R, which is 6 divided by 12, giving 0.5 amperes. So, the minimum power P min equals I squared R, which is 0.5 squared times 12, giving 3 watts. To get maximum resistance, we connect them in series. R max equals 24 plus 24, which is 48 ohms. The current I equals V over R, which is 6 divided by 48, giving 0.1 to 5 amperes. So, the maximum power P max equals I squared R, which is 0.1 to 5 squared times 48, giving 0.75 watts. The ratio of minimum to maximum power is 3 to 0.75. This perfectly simplifies to exactly 4:1. Alternatively, we have the OR question, part B. This asks us to first draw a schematic diagram of a series circuit containing a battery of 6 2-volt cells and 3 resistors of 6, 12, and 18 ohms. Based on this circuit, we must calculate 3 things. First, the total electric current flowing through the entire circuit. Second, the specific potential difference, or voltage drop, happening only across the 18 ohm resistor. And third, the electric power being consumed specifically by that same 18 ohm resistor. Let's solve this alternative part B. Here is the schematic diagram with the 6-cell battery, key, and the 3 resistors in series. First, find the total resistance by adding R1, R2 and R3. Total resistance equals R1 plus R2 plus R3, which is 6 plus 12 plus 18, giving exactly 36 ohms. The total voltage V is 6 cells of 2 volts each, totaling 12 volts. Using Ohm's law, the circuit current I equals V divided by R, which is 12 divided by 36, simplifying to 0.33 amperes. Next, the potential difference across the 18 ohm resistor. V18 equals I times R18, which is 0.33 times 18, giving exactly 5.94 volts. Finally, the power consumed by this 18 ohm resistor. Power equals I squared R18, which is 0.33 squared times 18, yielding 1.96 watts. And that's how you thoroughly solve circuit problems. Keep practicing and happy learning.